Our topic for today is Introduction to Pneumatics. A pneumatic system is a branch of engineering that uses compressed air to transmit and control energy. It is used extensively in various industries. Most pneumatic systems rely on constant supply of compressed air to make them work, and the concept of pneumatics are the same for hydraulic, but pneumatic transmit power using gas rather than liquid. Compressed air is generally used as nitrogen and other gases. With pneumatics, air is pumped into the receiver using a compressor. The receiver holds a large volume of compressed air to be used by pneumatic system as needed. Pneumatic devices get all their power from the energy in the compressed air they use. They need at least two components, something to compress the air, the compressor, and the actuator to lift, move, or hold an object. Manufacturing industries commonly use pneumatics, like packaging, robotics, material handling, and pneumatics can be useful in very specific applications where hazards are critical. For example, gunpowder factory, mining industries, where spark could be hazardous for explosion. Number 1. Compressor. A compressor is a mechanical device that increases pressure of a gas by reducing its volume. As air compressor compresses air under pressure, its temperature also increases. This is a simple law of physics known as pressure-temperature law. It will rely on the type of air compressor you are working. The air discharged from the compressor as hot as 250 to 350 degrees Fahrenheit. Hotter air also contains more moisture, which will result in excess water vapor that will condense in control lines and tools if it is not removed. We have several types of compressor like reciprocating, rotary, centrifugal, and axial compressor. Number 2. Pressure gauge. An instrument for measuring the state of gas or fluid that is defined by force. The gas or fluid would exert. The unit are pounds per square inch or newton per square centimeter. Number 3. Moisture receiver. Remove water and suspended contaminants. Number 4. Air receiver. Is used to store high pressure air from the compressor. Its volume reduces pressure fluctuations arising from the changes in load from the compressor switching. Any moisture left in the air from the compressor will condense out in the receiver, so outgoing air should be taken from the upper side of the receiver. Number 5. Air dryer. Used to dry compressed air in order to protect your piping, tools, and equipment. And it's best to use compressed air dryer because compressed air always contains water coming from the air that is sucked by the compressor. Refrigerated air dryers are the most common type of compressed air dryer. They remove water from the air stream by cooling the air to approximately 38 degrees Fahrenheit and effectively condensing out the moistures in a controlled environment. Number 6. Air pressure regulators reduce supply pressure to the level required for efficient operations of pneumatic equipment, and it will reduce a supply or inlet pressure to a lower outlet pressures and work to maintain this outlet pressure despite fluctuations in the inlet pressure. The reductions of inlet pressure to a lower outlet pressure is the key characteristics of pressure regulator. When choosing a pressure regulator, many manufacturers must be considered important considerations. Include operating pressure ranges from inlet and outlet. The parts of air pressure regulator are adjusting knob, pressure gauge, air filter inside, water drain knob, lubricator. If you want to adjust the pressure of the system, you need to pull this adjusting knob. By turning the knob clockwise, will lower or decrease the pressure from the valve. Keep track number of turns so that you can go back where you started. To replace the air filter inside, just turn counterclockwise the housing. Usually you need to replace the filter every 6 months, or it's depend on your planned preventive maintenance systems. Water drain knob, usually auto drain. If not, you need to drain it regularly. Lubricator. The purpose of lubricator to lubricate the line, o-ring, seal, and other components. Number 7. Directional control valves. Directional control valves are designed to change the flow of directions of air or fluid within a circuit. A valve is designed to control the directions of movement of work of a cylinder. Directional control valves perform 3 functions and usually operate in combination: stop air or fluid flow, allow air or fluid flow, and change the directions of air or fluid flow. The simplest directional control valve is the two-way valve. It stops flow or allows flow. A water faucet is a good example of two-way valve. Number 8 pneumatic cylinders are typically used on industrial machinery and rely on compressed air pressure from 75 to 110 psi. Pneumatic cylinders are more cheaper compared to hydraulic cylinders. Pneumatic cylinders offer more choices and sizes for easier integration into machinery. There are two common types of cylinder, single-acting cylinder and double-acting cylinder. A single-acting cylinder is one where output force is developed in one direction only. The piston is returned by a fitted spring. Double-acting cylinder is one where the thrust or output force is developed in both extending and retracting direction. Double-acting cylinder have a port at its end and move the piston forward and backward by alternating the port and receive high-pressure air, necessary when load must move in both directions, such as opening and closing the gate. This is the sample layout of pneumatic system. The one on the left is pressure regulating valve, and on the center is 5 two-way valve. Thank you for watching, and see you on the next video. If you like this video, please like, share, and subscribe. Have a good one.